Unbelievable.
I didn't ask, I found.
What's the rate, Logan?
Like how much you make a year, I'd say?
Okay, yep. So that would be like money
Yeah.
per time. Yeah, money per time. What's another rate, Cody? I know one.
I don't know.
Cody, you keep thinking of one. My rate, how many times Logan forgets a pencil
I did.
per week? I think it's about like 2.5. 2.5, yeah.
Yeah, I guess Friday.
Because some days you're good, some days you're not, right? But yeah, so just 2 units compared to one another, right?
Yeah.
So Cody, it could be how many bites of a sandwich you can eat in 15 seconds, right? Or how many how many drinks of Rockstar you can, have in 1 unit time, right? Good. Okay, so now we're gonna get into solving problems involving rates. Very applicable. You guys are gonna be doing this for your whole life, okay? So this is important. So, applications of rates. So, when might you see the following rates being used? 98.5 cents a liter.
Fuel.
Fuel. What year?
2015. No, after that, 2015, 2019.
I'm gonna go with 2010. I don't remember it being under $1. Actually, I guess it was under $1 a few times.
$1.
Well, you live on a farm and you get dyed fuel. I pay for municipal fuel,
Yeah.
and I don't remember it being under $1 in some time. I do have a short memory though, to be fair. So, okay, so fuel. Yeah. What about this next one? You guys should be familiar with this. Mbps.
Megabytes per second.
Yeah.
Okay.
Shred it. Is that fast or slow?
That's pretty slow.
Data, we can say. Data rates. That's slow.
Decently slow.
Yeah. What about the last one? 0.05 milligrams per kilogram. Milligrams per a conversion rate? No, because in 1 milligram, there are definitely more. Brandon, you're late.
Yeah, I can't find a pencil portion.
You guys crack me up. What did you rate with in last class?
Okay.
Social class, yeah.
I just sit there and listen.
0.05 milligrams per kilogram. That could be like a tranquilizer rate, maybe. It should be like a medicine dose, right? Maybe in, no. That would probably be like let's go with tranquilizer. Tranquilizer dose. Okay.
For the last half hour of this class.
What do you think you were doing for the last half hour? Question for you. If 20 pounds of sugar costs $115, how much sugar could you buy for $85? Where do we start?
I'd say trying to figure out how much like each pound weighs, I'd say.
Or yeah, perfect. Let's exactly do that. Let's find out how much
each pound weighs.
how much each pound costs, right?
Yeah, 1 pound costs $0.17.
So 20 pounds for $115. Did you just do that calculation? Yeah, what'd you get?
174.
0.17, right?
Yeah.
And because it's money, we're just gonna round to 2 decimal places, okay? So we know we get 0.17 pounds per dollar. Okay? Now,
You get 14.8 pounds.
how'd you do that?
Smart.
How'd you do it?
No.
I went 0.17 times by 85.
Okay, good. Now, that's excellent. 'Cause that's exactly what you're gonna do. Okay? But when you guys are doing this, you need to show me how your units are converting from one to another, okay? So, and again, we should not be rounding our intermediates, right?
Yeah.
You guys know that,
Mhm.
right? Okay. So we get, sorry, I want to write that differently. So it's 0.174 pounds per $1, right? And how many dollars are we spending?
85.
$85.
Okay, so what happens to my units? What's any number or any variable divided by itself?
0. I don't know. 1.
1, right? So dollars cancel. And what units am I going to be left with?
Pounds.
Pounds, right? And what did you get for your answer?
Oh, 14.7.
14.7?
Let me read.
14.8 or 14.8 pounds, right?
Oh,
So, what must we always include with our answers?
whatever. Pounds.
Units, right? LB. Okay, so what we did here, and what Logan mentioned at the beginning, he wanted to find the mass that we get per dollar, right? Does anybody remember what we called that from yesterday? If it's per $1.
It's a rate. Oh, that's a rise.
No, it is not.
Either of them.
It's not either of those. We don't have a graph here.
No,
right?
it's if it's
For one thing, it is our unit price,
okay.
right? Our unit price or our unit rate, right? And you guys could have found unit rate is what we said yesterday.
Yeah.
Slash price, same thing, right? You guys could have done it the other way around, right? You could have found out how many dollars you get per pound, right? And you could have done it that way, right? Yeah. Anytime you're doing a calculation like this, you must show your units, okay? And you will show your units. Okay. So, Paula is asked to order snacks for an office meeting of 180 people. So let's just write down what we know. Anytime you get a word problem, right? Write down what you know. 180 people. She decides to order dessert squares, which comes in boxes of 24. So how am I going to set up that unit? How many chocolates are in one box, Logan?
24, so 24 eggs, I'd say.
No, you don't have to do that, but we're just going to go like this.
Okay.
So 24 chocolates per one box. Okay. She wants 2.5 squares per one person. How many boxes should she purchase? Logan's jumping his calculator. Great. Logan's already crunching numbers. My question is, I wonder what numbers he's multiplying together and why. What numbers did you put in, Logan?
I just put 180 divided by 2.5 squares and then 17.
Oh, okay.
That's not correct. That'd be 72 people.
Yeah, so that is
Oh,
not.
fuck.
And see, our units are going to help us make sure that we get the right numbers, okay? So I want you to look at this. We have 180 people, right? How many squares does each person get?
2.5.
So it's like
She'll need.
we're gonna have like triple almost the amount of squares per people, right? So we want to multiply that.
Oh.
Cool. And Logan, what's gonna happen to my units if I multiply 180 people
she'll need
by
18
2.5 squares per person?
She'll need 18.75, or I guess 18.8 boxes. chocolate, which would actually be 19 boxes of chocolate.
Okay, we'll get there. You jumped a little bit ahead, but that sounds right, Cody. Yeah, you are exactly right. Okay? But Logan, what's gonna happen to my units here? If I'm multiplying 180 people by 2.5 squares per person.
It would be equal squares.
Only squares, right? Yes, exactly. People will cancel. And then we get what? So that tells us we need 450 squares. Right? Or chocolates. Chocolates, squares, right? Those are interchangeable, so I apologize. But okay? We have 450 squares. But what do we want to find? How many boxes we need, right? So what did you do next, Cody, from this point?
450 divided by 3.5. Or sorry, 450 divided by 24.
Okay, 24 chocolates, or I'm gonna just say squares. Squares per box, right?
Yeah.
What is any number or any variable divided by itself?
1.
Yes?
So it'd be in boxes.
Squares go away when when you have like a denominator in the denominator. Does that make sense? Like when you have a fraction in the denominator, if you're dividing like this becomes the new numerator. Okay? Yeah. So once you do that, exactly, divide that, and then we get 18.75 boxes. And Logan, can we buy 3/4 of a box?
No, you have to round up to 90.
Perfect. So therefore, Paula needs 19 boxes.
Right, you ready for that? You know the heart, all the heart? That's like the biggest question.
All right.
I'll take 6.
Okay. This is our last question for the day. Okay. So Amelia walks briskly at 6 kilometers per hour. And when she walks at this rate for 2 hours, she burns 454 calories. Okay? So anytime you have a word problem like this, right? Write down what you know when you read it. Okay? So, you guys have Amy. We have Amy on the board and I have Amelia over here. Maybe Amelia likes to go by Amy. Yeah.
Yeah, I got Amelia as well.
Yeah, me too. And that's okay. So let's go with Amelia then, just to confuse whoever's watching this video. Okay, so Amelia walks at, so her speed, S, is 6 kilometers per hour. If the time is 2 hours, she burns 54 calories. 454. Holy moly. Amelia. That's quite a lot. Okay. Brucey boy. He's a little bit more slow, right? Yeah. He's just cruising. So Brucey boy, he walks at 4 kilometers per hour, burning 62 calories in 30 minutes. So 30 minutes, we got to make sure units is the same, right? So how much of an hour is 30 minutes?
Why don't we just do it 2 minutes?
Because this is in hours, this is in hours, this is in hours.
That'd be half an hour.
Yep, exactly. So 0.5 hours. And that's an easy enough conversion, right, Logan? Okay, and then he burns only 62 calories. Because he's slow. Right? So,
Bruce will have to walk for 11 hours.
nope. Nope. So what did you do first,
Oh,
Cody?
Bruce will have to walk for 5.5 hours.
Yeah.
Yeah.
Okay. But how did you? Can you explain your thought process for us, Cody?
I went 454 divided it by 2,
Yep.
and then I added that, whatever that divided by 2 was onto that 454.
Okay. So slow down for a sec. So why did you divide that 454 calories by 2 hours?
I just divided it by 2 so I could know what the third was. A third of it was. Because it said, that's only for 2 hours and she needed 3 hours, so I just divided it by 2, got that number, and added it onto there.
Mm-hmm.
Then I got that number and I divided it by 62 calories.
Okay, so when you divided your 454 calories by the 2 hours, you found the unit rate.
Yeah.
The unit rate, okay? Use our vocabulary, please. Okay? So, yeah, that's exactly what we're gonna do. So, we're still for Amelia. So we wanna find her base rate, how many calories she can burn in 1 hour. So we know she burns 454 calories in 2 hours, right? So in 1 hour, she can burn 227 calories per 1 hour. Right? Is that all good? Okay. Now, how long was she running for?
2 hours?
3 hours.
Oh, 3 hours.
Right? So, hours, units cancel. Not the 3. The 3 is still there for sure. Okay? And then we get 681 calories she burns if she runs or if she walks for 3 hours. Okay? So,
Must be severely overweight.
Yeah.
what?
Burns 681
She gonna
calories in
eat?
3 hours?
Dude, walking at 6 kilometers per hour? It's pretty fast.
Yeah, true. Actually, I don't even.
6 kilometers per
Yeah,
hour?
you couldn't even walk
That
that fast, I think,
is,
on
that's
the-
1 kilometer every 10 minutes.
Yeah.
So that's pretty quick.
Yeah.
Is that possible though?
Yeah, of course it is.
Oh, definitely.
You'd have to be like speed
Yeah.
walking.
Yeah,
You'd have to be moving.
You would definitely have to be moving. Yes. Yes.
So you have to move to move.
You do have to move to move. You gotta spend energy to get energy. Okay, Logan, what are we gonna do for old Brucey boy over here?
We would do. We do the amount of calories he burns in half hour, and we do.
And once we do that, what do we find when we do that calculation?
We could find out how much he burns in an hour.
And what do we call that?
Unit rate.
Exactly. Okay, we want to find our unit rate here. Okay, so 62 divided by 0.5 is 124 calories per 1 hour. Okay, 124 calories per 1 hour. Okay, so what? The question is asking, how much longer will Bruce have to continue to walk to burn the same amount of calories?
5.5.
And how did you find that, Cody?
Well, I did it completely different, but.
Okay, but okay, fine.
I just went 681 divided by 62, and I got 11, and I got 11 point. Or yeah, I got 11, and I divided 11 divided by 2.
Okay, so when you're doing something like that, make sure you are showing all of your work and you're showing your units canceling, okay? Okay, so is what I did to find this. We know that Bruce is moving at 124 calories per 1 hour, right? And we're asked how long it's going to take him to get to that 681, right? So what we're going to do, we're going to do 681 calories divided by 124 calories per hour. What's going to happen to my units, Cody?
Calories are going to cancel out, it's just going to be an hour.
Yeah, perfect. Okay, so calories will cancel, and then we're just going to be left with 5.49 hours. What was the question asking, Cody?
was asking how many hours would it take Bruce to catch up to Amelia.
No.
How
It was
many-
asking-
how many hours would Bruce have to walk to burn as many calories as Amelia would in 3 hours?
The question was asking how much longer will Bruce have to walk.
Yeah.
So if he's already walked for how long?
Half hour.
Half an hour?
So he's only gonna have to walk 5 hours.
Well, around like 6.
Whoa, other way of voice?
Oh, I know, I know.
I said 5 hours.
4.99
Oh,
hours.
you were wrong, Cody.
And you know, if Bruce really doesn't like slowing that one, you know, the 1% of an hour,
Yeah.
which is not even a percent,
No.
it's like 20
It's
seconds.
like not even 20 seconds.
Maybe a little bit less.
4
It'd be around there, right? Okay. So that's all that I have for you guys today.
Wow.
Homework
Holy shit.
for an hour.
2, 4, 6, 8, 10, 12.
Yeah, just
14.
work on stuff for an hour, right? We have a hour and 7 minutes. You guys have a quiz tomorrow on this stuff, okay? So what we covered yesterday and what we learned today, okay? So 8.1, 8.2. Here is our key concepts. So can you convert rates into unit rates, like we were doing today, right? If you had like 13 liters per 14 liters per gallon. Why is that a measurement? Why does that sound familiar?
That's
Liters per
14
gallon?
liters per gallon?
No, because that's not. Let's do liters per kilometer. Let's pretend we're moving like the most inefficient thing. We're trying to move the school. Okay, so you would want to find out how much liter you get per 1 kilometer, right? So 13 divided by 14, that's got to be.
1.1.
No, it's gonna be smaller. It'll be
Oh.
like probably 0.96 around there, liter per 1 kilometer, right?
That's not
Approximately.
that bad if you're moving to school.
A liter per kilometer?
Yeah.
Yeah, actually, you're right. You're right. Read and interpret graphs and determine the slope of the line on a graph, right? How do you guys feel about slopes?
Fine.
Okay? Slope is rise over run, which is delta y over delta x, right? What usually goes on the x-axis?
Time.
Time.
Yep, time, okay? And y is gonna be like your responding variable, right? Yeah. Solve, set up proportions and solving them like what we did today. Okay? And that's it.
Alright.
So I think you guys are gonna be A-okay.